Now that we've dealt with the law of sines, let's look at the law of cosines. For the law of cosines, we start with our triangle with angles denoted by the capital letters A, B, and C, and the side opposite them denoted by the corresponding lowercase letter. There are 3 laws of cosines. The first says a squared is equal to b squared plus c squared minus 2bc times cosine of a. The second says b squared is equal to a squared plus c squared minus 2ac times cosine of b. And third, we have that c squared is equal to a squared plus b squared minus 2ab times cosine c. And these can help us solve the triangles that we can't solve with the law of sines. There are 2 particular cases. The first case is side angle side. We know 2 sides and the angle between them. The first thing we're going to do is use our law of cosines to get our third missing side. We're then going to use our law of sines for the shorter side. That's going to get us an angle that is guaranteed to be acute. So we're going to eliminate that ambiguous case for the law of sines. So we always want to use our law of sines on the shorter of our options. And we'll then find the missing angle, our final angle, using the fact that the angles of a triangle have to add up to be 180 degrees. Let's look at an example. Here I have my triangle where I have 2 sides and the angle between them. I'll call this angle A. That tells me that this missing side is side A. If this is angle B, then side B is 20. And if this is angle C, side C is 30. I'm going to use my law of cosines that's equal to a squared since that's what I'm missing. And that's equal to b squared plus c squared minus 2 times b times c times cosine of angle A. This gives me that a squared is equal to 400 plus 900, and if we type this last expression into a calculator, we get that 2 times 20 times 30 times cosine of 60 is 600. 400 plus 900 is 1300, minus 600 is 700. And we need to take the square root of this to get just a. This tells us that a is about 26.5. So this is our missing side. We used our law of cosines to get the missing side. Next is to use the law of sines. The only angle side pair I know is for A, so I'm going to start with that. 26.5 divided by sine of 60 degrees. And I said I wanted to use the shorter of my 2 sides, so I'm going to use 20 since 20 is smaller than 30. So 20 is side B, so this will be over sine of B. 26.5 times sine of B is equal to 20 times sine of 60. If I multiply out this right-hand side, I get that this is approximately equal to 17.32. I can divide both sides by 26.5 to get that sine of B is approximately 0.65. We can then take the inverse sine of B, or of 65, to get approximately 41 degrees. So angle B will be approximately 41 degrees. And since we purposely picked the smaller side, we don't have to worry about that ambiguous case in the law of sines. Finally, we can find our angle C using the fact that the angles of a triangle have to add up to be 180 degrees. This tells me that 180 degrees is equal to 101 degrees plus C. Subtracting 101 from both sides gives me that 79 degrees is equal to C. So my final angle is 79 degrees, and I've solved this triangle. The final type of triangle that I want to look at that can be solved using the law of cosines is side, side, side. I know all three of the sides and none of the angles. We start by using the law of cosines on the longest side. This will give us one of our three angles, in particular our larger of the three angles. We can then use our law of sines on either of the other two angles. Since I've already dealt with the biggest angle, I am ignoring this case of the ambiguous law of sines. So by using law of cosines on the longest side, I don't have to worry about the case of two triangles appearing in the law of sines. And finally, I can use the fact that the angles of a triangle have to add up to be 180 degrees to find my final angle. Let's solve this triangle here with side lengths 9, 6, and 4. Our first step is to use the law of cosines on my largest side. I'm going to call this side A, this side B, and this side C. 9 is the largest side, so we're going to use that one. It says that B squared is equal to A squared plus C squared minus 2 times A times C times cosine of angle B. 9 squared is 81, 6 squared is 36, 4 squared is 16, 2 times 6 times 4 is 48. "36 plus 16 is 52. We can then subtract 52 from both sides. That gives me that 29 is equal to negative 48 cosine B. Dividing by negative 48 gives me that approximately 0.6 is equal to cosine of B. And then we just take the inverse cosine to figure out the angle. When we do that, we get that angle B is about 127 degrees. So this triangle is definitely not drawn to scale. Now that I have angle B, I can use my law of sines. I know that 9 over sine of 127 degrees is equal to 6 over sine of A. We can cross multiply to get 9 times sine of A is equal to 6 times sine of 127 degrees. Using a calculator tells us this is 9 times sine of A is equal to about 4.78. Divide both sides by 9 to get that sine of A is about 0.53. We then use the inverse sine function to find the angle, and we get that angle A is about 32 degrees. So now I have two of my three angles. Finally, we can use the fact that 180 degrees has to be equal to 127 degrees plus 32 degrees plus angle C. 127 plus 32 is 159. Subtracting 159 degrees from both sides gives me that my missing angle is 21 degrees. So this angle up top will be 21 degrees. And I now have solved my triangle.